Okay, we're going to have a look at fourth degree polynomials now, and a fourth degree polynomial is referred to as a quartic. Kind of makes sense, quarter being a fourth. Okay, so it's fourth degree, which means my x is to the power of 4. All right, now the nice thing about my quartics, okay, you can see here, if we have a positive quartic, they don't look not unlike, they're not unlike a parabola in the way they look. Okay, if the graph is just x to the 4, all right? So the only real difference between the two, if I draw undo that. If I come over here, if I was to do a parabola, I'd probably do it a bit like that. Okay, my quartic, however, the 0.11 and -11 would be the same. They both go through that. All that difference is the quartics, they're steeper, so they're straighter, and they've got a flatter bottom. All right, but for all intentions and purposes, if you have a look at the graph of just draw a parabola type shape, if you're doing a quartic, that'll be perfect. All right, and as you would expect, the translations and shifts are exactly the same as what they were for our parabola. If we have our quartic of this form here, well, let's go back a bit. I guess domain is R. The range of the graph is R plus with 0. All right, so we hit 0 and turn. So again, this graph here, K units up, all right, H units to the right, all right. So it's exactly the same principle. So if we just do a couple of quick sketches, we can see that our graph has gone right 2 units, down 4 units. So we'll call that 2, and I'll call that 4. So it's positive, so it's something like that. All we need to do now is find some intercepts. All right, so again, how do we find intercepts? Well, x-intercept, I'll put y equal to 0. So 0 is equal to x minus 2 to the 4 minus 4, 4 across. Now this time we'll take the 4th root, okay? And because we're taking an even number, it's plus or minus the 4th root is equal to x minus 2. Take the 2 across, so x is equal to 2 plus or minus. Now that 4th root, if you like, the 4th root of 4 is the same as the 4th root of 2 squared, yeah, which is the same as 2 to the half, which is root 2. So it is possible, if your thoughts are cancel it down, you might get a plus or minus root 2. So it's 2 minus a number smaller than 2, 2 plus a number smaller than 2. So my intercepts are going to be both on that side. Y-intercept, put x equal to 0. So if we put x equal to 0, y-intercept, x equal to 0, I get y is equal to 0 minus 2 to the 4 minus 4, which is -2 by -2, which is 4. 4 by 4 is 16, minus 4, which is equal to 12. So you can see that whilst it probably doesn't fit our scale, my graph is going to come down, just maybe make it a little bit flatter on the bottom, and then bring it back up again, okay? B, very similar. So y-intercept, let's put x equal to 0, and we'll get y is equal to 0 plus 1 to the 4 plus 2, which is just equal to 3. X-intercept, put y equal to 0. There we go. Y equal to 0, what am I going to get? I'm going to get 0 is equal to x plus 1 to the 4 plus 2, negative sign across, cube root, which is the same as plus or minus, the 4th root of -2 is equal to x plus 1. So then x is equal to 1 plus or minus the fourth root of -2. Now, straight away, we're going, well, we can't have that because the fourth root of a number, the fourth root of a negative number doesn't exist. So there is no x-intercept. So does that make sense? Well, what's my graph doing here? It's shifting 1 unit to the left, and we'll call that 1 unit to the left, and 2 units up. So no, it doesn't have any intercepts because my graph's going to come down. We said it goes through 3. We'll call that 3. And it's going to look something like that. Okay, so that's when it's in that x to the 4, and we're going to add and subtract and shift it left and right sort of shape. If it's in a more general form and we've got factors and intercepts, other intercepts, I guess it's a little bit like our cubic. So the different choice, okay, for an x to the 4 graph, we can have 4 individual intercepts. I don't know. Okay, that means our graph will go something like that. All right, so maybe there's the 4 intercepts. All right, we've got 2 negative, 2 positive, so we might look something like that. All right, the other option we might have one of them squared. And from our work with our cubics, we know if one of our factors is squared, it's a turning point. So that would make that a turning point. We've got one over here at -1, one at +2. So our graph might look, I'll change the color, might look a little bit up. We come down to the turning point, and then we might come back down through. Now that's actually a negative graph because it's top and bottom. It's heading downwards, okay? But I guess the point is it's a 4th graph. So we're going to have possibly 3 turning points, all right? If my factor is repeated, that factor is a turning point. The last little possibility, might come over here, is if my graph has got a cube function. Okay, so I know it's a quartic because it's x cubed times x, which is x to the 4. That -1 there makes it +1. That's a point of inflection. So it's going to go like that or like that, like a cubic, and -1 is an intercept. So it's a positive. So what if we go -1 comes down, it turns, and then we have a point of inflection there, and then it continues up. All right, so they're the different possibilities we have for our graphs. All right, so keeping that in mind, let's just do a little bit of solving first. So that little bit of solving involves, all right, let's factorize. X is common. X comes out the front. I get x cubed minus 8, which is the same as x cubed minus 2 cubed. Now, if we remember our difference of cubes expansion, I get x minus 2 out the front of. I get x squared plus 2x, because it's a minus inside, plus 4. All right, so that's going back to our formulas. That's equal to 0, all right, which means that doesn't equal 0. So I get x equal to 0 and x equal to 2 are my solutions. All right, what about this one here? I've got x squared is common. So I can take x squared out the front. That gives me x squared minus 8x minus 24. All right, so there's my parabola. Can I factorize that one? So 8 3s are 24. 6 4s are 24. I can't think of any nice numbers here, lads. 12 2s. No, so it's not going to factorize nicely. So that means we're going to have to factorize it. Well, we can factorize it, or you can use your quadratic formula. I'm going to go for complete the square. So let's see x squared, and then in blue complete the square. So I'm going to write x squared, halve it and square it. So it's plus 16 minus 24. So x squared outside of perfect square minus 4 all squared minus 40. Okay, so now my solutions. This one here gives me x equal to 0. If I solve that equal to 0, I get x minus 4 all squared is equal to 40. X minus 4 equals plus or minus the square root of 40. So x equals 4 plus or minus root 40. Well, it's the same as 4 times 10, isn't it? Root 4 by root 10. So we'll call that 2 root 10. All right, so there's my intercepts there. I guess just to confirm, that one wouldn't have solutions. If I complete the square on that, I can go x plus 1 all squared. So it's going to be plus 1 minus 1 plus 4 plus 3. And there's going to be no solution for that equal to 0. All right. So my solutions are, now it's just to sketch the graph. So there's my intercepts. There's my graph. So let's get I've got x-intercepts. What about my y-intercept? I'll put x equal to 0. If x equal to 0, I get 0. So a y-intercept is at 0, 0. I've got an x-intercept at 2. I wonder if I can get away with doing that as 2. My shape is a positive. Yeah. So since that's the only information we've got, and more than likely this is a calculated graph, all we can really do is just draw. We know there's an intercept there. We're not too sure about turning points at this stage. So all we can sketch is something that looks a little bit like that. Okay, I've got my x-intercept at x equal to 0 and 2. And so we'll just sketch our graph along those lines. What about our next one? We know we have, let's again get our y-intercept. So y-intercept, x equal to 0. And again, that means y is equal to 0 as well. And in fact, at x equal to 0, it's a squared factor or a squared solution. So that's going to be a bit of a turning point there. It's a positive, so it's going to come down and go up that way. We have intercepts at 4 plus 2 root 10, which is clearly going to be, we'll say over here somewhere. Now, how big is 2 root 10? Well, the square root of 10 is slightly bigger than 3, isn't it? Because the square root of 9 is 3. So it's 4 minus 2 times 3. So it's going to be a negative value. So we'll put it over here somewhere. And my graph has, I know, a turning point here. So it's a positive quartic. So we start up in the positive section. It comes down. It turns somewhere. It goes through 0, but it's a turning point at 0. And then it comes up through, okay, 4 plus 2 root 10. I don't know where the turning points are, boys. So these ones here, they could be higher, they could be lower, they could be closer. We don't know, all right? We can analyze it on our graph, all right? But otherwise, we can't do a hell of a lot. So let's just look at this last little Inspire screen. What's that telling us? Okay, that's just solving our volume equal to 100, all right? So I reckon that graphic belongs in our next example. So we might come back and reference that soon, all right? Have a go at sketching a few quartic graphs, all right? So it's just basic shape. You know, most of the graphing, as long as we can do just the basic shapes of them, that's all we need.